bench wall in the L-train tunnels, in some places it's intact and fine. In some places it is slightly weakened. In some places it is crumbling. The places where it's crumbling are the places where the salt water was the highest and remained the longest, because the salt water got into the cracks in the bench wall, and the salt sat and the salt deteriorated the bench wall. This picture, you can see the pipes in the bench wall. Within that pipe is the power cable. Okay? That's the way they did it. The current plan was remove the entire bench wall, remove all the conduits, remove all the cables. That's 32,000 feet of bench wall between the two tunnels. Install all new cable, and then rebuild the bench wall. That was the plan. It was labor intensive because much of the bench wall had to be removed by hand. It's a 100-year-old tunnel. You're taking out a cement structure attached to the lining of the tunnel, so it would have to be broken up by hand and removed. I'll start where I ended. I asked Columbia and Cornell to assist the state of New York as good citizens of the state of New York. They agreed. The dean of the engineering school of both Columbia and Cornell put together teams, went through the whole process, went through the tunnels, and I said to them, any new idea, outside of the box, creative, any way to reduce the 15 months, we are open. Let the MTA say that's an idea that just is beyond reality. Or confirm that this is the best way that we can do it. So I have confidence in saying to the people of New York, this is the shortest, best route to the rebuilding of the tunnel. Again, I want to thank them for their work, because they did work very hard. They've all mentioned individually that I was a pleasure to work with. Slight editorial comment. But with that, I'm going to turn it over to Mary Boyce to walk us through the first part of the program, and then you'll hear from Dean Collins, but first we'll hear from Dean Boyce.
Okay. So thank you all for coming to hear our story. First, I want to, on behalf of both the Columbia and the Cornell teams, to thank Governor Cuomo for inviting us to participate in looking at the incredible challenge, and rather unique challenge, as you've heard, on how do we address the L-train tunnel. And recognizing there's been a lot of work done before, but how can we come and give a new look to this problem in collaboration with MTA and others. We realize what a privilege it is and an honor to be asked to serve in this capacity, that this impacts hundreds of thousands of lives of New Yorkers, and many of us on the team are New Yorkers too, and also the impact on so many businesses. So we do appreciate the gravity of this task. So when we look, let me first introduce our team. As you've heard, I'm Mary Boyce. I'm Dean of Engineering at Columbia University. I'm a mechanical engineer. Lance Collins is Dean of Engineering at Cornell University, also a mechanical engineer. Andrew Smith, a professor of civil engineering at Columbia University. Tom O'Rourke, a professor of civil engineering at Cornell University. Peter Kingett, a professor of electrical engineering at Columbia University, also chair of the Department of Electrical Engineering. George Diodatis, a professor of civil engineering at Columbia and chair of the civil engineering department. So we've actually, over the last 3 weeks, literally spent hundreds of hours collectively working on this project. As you've heard, we've toured the L train tunnel. We also toured the Hudson River Tunnel, the Amtrak tunnel. I also want to say what a collaborative effort this has been, that we've worked very closely with consulting firms, WSP and Jacobs, and various contractors, with very closely with the MTA and New York City Transit. This has been an incredibly team work focused collaboration and very productive. In particular, I do want to mention three people who led different teams: Pat Foy from MTA, Charlie Hall, and Jerry Giannetti from WSP, and their entire teams have been so instrumental in all that we've done. As part of our review, we did look at what are some of the designs and systems used in more modern tunnels across the world, to see what we could learn from those practices. As was mentioned, some of the tunnels we looked at: London, Riyadh, Hong Kong, also Singapore. That one of the things you've heard about the bench wall. You're going to hear a lot more about that in a few moments. But we have found that in newer designs, the cables are not placed within bench walls, right? Also, if you can get a little bit of a look at these tunnels, cross sections, you also see that there's a lot more space around the train in these newer tunnels, right? So that's also an important factor. So let me start with the recommendations. So our recommendations, while we're going to go through them in a little bit of a linear fashion, are really a result of looking at a highly integrated system of bringing together emerging and new technologies from little bits and pieces from many different proven technologies that are out there. And these have led to our primary recommendation that we recommend implementing a new way to do the power, control, and communication systems, and how to embed these in the tunnel. So the tunnel cross-section you're seeing here is the L train tunnel cross-section. So within that, not to bore you with all the details, but as engineers we can't help ourselves sometimes. That you can see the cross-section of the train, and you also see this yellow envelope, and that's kind of the keep-away envelope, meaning that everything outside the yellow envelope and within the walls of the train is the space that we have to work with. So this is another challenge. It's a highly tight space, highly geometrically confined area that we get to work with. So you can see why cables are in bench walls in a tunnel like this, right? Because they fit, okay? And they get protected and all of the other elements that you've heard. But we said, let's not be confined by that. Let's think more broadly, right? So I'm going to focus first on the cables, and then I'll hand over, and Dean Collins will talk about the details in the bench wall and others. So we're going to we are recommending that the cables be racked. Okay, so the majority of the cables, the power cables, the communications cables, control cables, these power the train, the pump, the fans, that these be racked along the walls on one side. This leaves the other side free for egress and access. All right. So, and we have looked at many challenges with actually doing this, and different ways to actually rack these cables. And we have found that it does indeed seem to be possible. We will also place the negative return on the track bed. So what this is essentially doing is decoupling the cable system from the bench wall, right? These are two different functions. We're able to execute all of the functions of the cables without them being in the bench wall. So we do not give up or sacrifice any functionality of the system. Right? An important thing that we have to address is making sure that the fire retardancy is still possible for these cables. So the cables must be jacketed, and they're jacketed with a low smoke, zero halogen fireproof material. Okay, and this is a proven technology. It has been used in these newer designs, in newer modern tunnel systems. It's also used in aircraft, right? And so what happens with these jacket cables, okay, is that yes, there's some sort of thermoplastic or thermoset, but they have an inorganic filler so that they char in the presence of heat or fire, and so there's no outgassing, and they actually become even better insulated. So this is another key feature of being able to rack these cables on the wall and not embed them in the bench wall. This also very importantly means that we can abandon all the old cables in the bench wall, right? We do not need to remove them and replace them. We just leave them there. So if a bench wall is still structurally sound, we do not need to destroy it and remove the cables and rebuild it. Okay? This is a very key factor, okay, so because it significantly reduces demolition and construction, and we feel probably has a cost implication as well. Okay, I'm going to now hand this over to Dean Collins, who will talk about the bench wall.
Thanks, Mary. Let me also add my thanks to the governor for giving me an opportunity to work on this project. This has been an incredibly exciting 3 or 4 weeks that we've had a deep dive and have learned a lot about the Canarsie Tunnel. So I'm going to pick up the conversation from where Mary just left off and talk a little bit about the bench wall. As the governor mentioned in his opening remarks, we're going to place the bench wall into 3 categories. So there's bench wall that's going to, in some sense, be stable and will remain. There's bench wall that's been compromised to some degree, but not significantly, that we think we can reinforce using something called fiber reinforced polymer. So it's essentially a mixture of epoxy and fiber to wrap around. And if you look at the figure to the right, you'll see essentially wrapping it around the bench wall and strengthening the bench wall. This will last for decades, you know, for a long period of time. It's not a quick fix. It's technology that's been widely used in bridges, in buildings. So we're simply applying it in a very different application here. And then there's a third category, which is bench wall that really is just not structurally sound, that has to ultimately be demolished and removed. Then the question becomes, how do we know what's what? And so we're going to use a state-of-the-art ultrasound technology to evaluate the entire length of the bench wall and figure out, you know, which parts of the bench wall are in which categories, and then and act accordingly to either leave it as it is, or to reinforce it as needed, or remove it as needed. And what's important is that the bench wall is really serving the primary purpose. It's back to its primary purpose, which is access and egress. It's no longer serving any role with respect to the cabling, and so that's the only element that we have to ensure in terms of functionality that we have retained. In addition to this, one of the concerns that you have is, well, the bench wall at one period of time may be in one state, but it may deteriorate over time. How will you know if that's happening? And so, in addition, we are going to install smart fiber optic sensors. These are sensors, it's a fiber optic cable that'll run along the vertical side of the bench wall, along the length of the tunnel. And these sensors will be able to pick up small changes and deformations in the bench wall in advance of failure, so that if there were something that eventually is going to fail, we'll know that in advance and be able to send in a team to go in and do whatever's necessary, reinforce that section as needed in advance of the actual failure. So this is really state-of-the-art technology. It's been applied in new tunnels. This is an unusual application in that we're applying it in as part of a rehabilitation of an existing tunnel, but it's proven technology. And so I think that the fact that it's proven technology means that it will work beautifully here. But we're not going to just stop there. So the other thing we're recommending is that we introduce a LiDAR system. What LiDAR does is it essentially maps out the shape of the tunnel at a given instant in time. This is not going to be continuous monitoring like the fiber optic cable. In this case, this is going to be something that we would mount, for example, on a train. And as the train is passing through the tunnel, it would do a reading of the tunnel. So it would be sort of periodic. But it would add a second and a complementary evaluation of any sort of deterioration that might be going on within the tunnel. So with these two pieces of technology, we think we will be able to know in advance if any section of the tunnel is showing signs of deterioration and be able to head off any more significant things that might happen. For example, if there were sort of structural loss and into the actual train area. So both of these are, as I said, state of the art, and we feel, but on state of the art, but on the other hand, proven. And I'll just mention that this is the baseline of what this technology can produce, but there are constant advances that are going on with the technology. Once deployed, we will continue to try to get more and more additional information from the signals coming out of those cables. So for example, the cables can pick up vibration. So as trains are going by, we would be able to see if the vibration signature is changed over time. And that may indicate sort of problems that may be going on, not in the bench wall only, but also in the track system. And so there's not only the sort of the immediate benefits that we see happening, but in fact, over a longer period of time, and as the sophistication of this technology grows, even higher level understandings about the operations that are going on within the tunnel. Of course, we've removed some of the bench wall, and so we're going to have to install a walkway where the bench wall no longer exists. We imagine that this could be just fiberglass, steel. It would be relatively simple installation, certainly a lot less expensive than reconstructing the concrete bench wall. So we see a savings as far as that's concerned, but we would still have a pathway from the standpoint of access and from the standpoint of egress and from the standpoint of safety. We also looked very carefully at the resilience. This is not going to be the last, as bad as Sandy was, it's not the last storm that New York is going to experience, and so we wanted to make sure that the tunnel is more resilient than it was before. We're making 4 recommendations to improve the resiliency of the tunnel. The first is that we want to increase the pump capacity for the tunnel. So as it currently stands, there's a single drainage pipe. We will have, in fact, now drainage pipes that will run to the Manhattan side and to the Brooklyn side, so that we can double the amount of water going through those pipes. In addition, we've increased the pumping capacity of the standard pumps and of the emergency pumps to dramatically increase the amount of water that can be pumped out of the tunnel during under emergency situation. The second thing is we looked at how those pumps are powered. Obviously, they only run if they're going to be powered. And so there are utility lines that are going to run from Manhattan into the pumping station and from Brooklyn into the pumping station, providing one level of redundancy. So if one of the grids goes down but the other grid is up, then the pumps are continuing to run. In the event that both of the utilities go down, though, then you need to think about an external generator to provide that power. So we are recommending that a permanent generator be installed. Moreover, we would like to explore the option of possibly powering that generator using natural gas rather than a diesel fuel. The advantage of having it powered by natural gas is that the emergency generator would be able to run indefinitely, so that it would not stop running when the diesel fuel, as it would with diesel fuel when that ran out, when the tank ran out. And of course, under conditions that we're talking about, and sort of a major storm is hitting, there's just a lot of things going on at the same time. And so the notion that this external power would be there indefinitely would add certainly to the resilience of the tunnel. Third is that and there's a demonstration of this shown here with the Queens Midtown Tunnel. The consideration should be given to potentially putting a watertight gate on the two ends of the tunnel to protect the tunnel from any sort of major flooding. So I'm showing an example here of in front of the Queens Midtown Tunnel. The Brooklyn Battery Tunnel has something very similar, and so there should be some consideration given to that. So that's our third recommendation. And fourth, there's a lot of vent shafts and so forth that run along the entire length of the tunnel. That's where the water is going to get in, and so we're recommending that all of those openings, that some sealing facility be sort of built into all of those between the First Avenue station and the Beverly Avenue station, especially all of those that are under some critical elevation. And so that should be something that's examined and implemented as needed. And finally, I just wanted to point to the fact that public safety was always in our mind. It was in every conversation that we had. And there were really sort of two aspects of it that we discussed at some length. One had to do with the actual construction project, and one had to do with the operation of the tunnel after the construction. So during the construction, the demolition of the duct banks and the removal of the duct banks is going to generate a good deal of dust, and importantly, airborne silica, which is a hazard for humans. And so part of what the construction company will have to do is monitor that and ensure through filtration and remediation that the air has been cleaned before that tunnel could then be reopened. So we made an additional recommendation beyond just having the company itself monitoring, but there should be an external independent evaluation and monitoring of air quality to ensure this is sort of public assurance that in fact the air quality is as is needed. And then in terms of the ongoing operations of the tunnel, as already mentioned, we're recommending this smart technology be introduced. This will monitor the structure of the tunnel. This is in some sense raising the quality of safety within the tunnel even beyond what it is today by introducing this technology. And so we conclude that in sense we're leaving the tunnel safer than it was originally. So let me just quickly run through those all of the recommendations that are being made. So we start with a new power and control system, as was stated, and in fact implementing a racking system for hanging the cables outside of the bench wall. This decouples the cables from the bench wall and allows us to then treat the bench wall in a somewhat simpler way and not comprehensively remove all of it, but in fact only remove that portion that is needed. We want to jacket the cables with a fireproof material that is also low smoke, so that in the event of a fire, people are safe. We'll abandon the cables that currently exist within the bench wall. There's no environmental concern there. We will leave the structurally sound bench wall in place, reinforce the less structurally sound bench wall, and remove the unstable bench wall. Number 7, we'll install a smart sensor system that is state-of-the-art to monitor the structures initially, and ultimately, I believe, the operations within the tunnel. 8, install a walkway so there continues to be a pathway for access and for egress under emergency conditions. 9, install and improve the resiliency of the tunnel in terms of any future storms that may be coming along. And 10, as I mentioned, we always had public safety in mind as we went through this exercise.
So to quickly summarize what are the benefits from this, first we see that the new system design is a highly integrated design, and it achieves all functional outcomes. And at the same time, it's reducing the work and this is happening because it allows some simultaneous and not sequential execution of the critical elements. Importantly, because we are racking the cables, that the old cables remain functional while we're actually placing the cables. And this is an incredible process change, which is what leads to the outcome of no closure, which was preempted by Governor Cuomo. The racking system allows greater access to the cables for inspection and future upgrades. So as we have newer technologies arise over the coming years and decades, we will be able to replace and upgrade much more easily than if these were embedded within a bench wall. The installation of the smart sensor system allows for the monitoring of the bench wall, but also, as you heard, other aspects of the tunnel and the train system on a continuous basis. This is actually helping bring us in to usher in the era of big data as part of actually monitoring and knowing what's happening in our tunnels. Okay, this will create a state-of-the-art capability here in New York. The upgrades to the pump system and the rail can occur in tandem. These were planned and they can occur in tandem with the cable and bench wall work. Okay, so there's no compromising on those upgrades. And we see a dramatic reduction in what we refer to as the non-value added project scope. So we don't reduce the scope, but we eliminate those parts of scope that had no value. For example, if we do not need to remove the bench wall and reconstruct the bench wall, we're not going to do it. And that's an incredibly time-intensive, labor-intensive element that we remove. It had no real value when we do not need to do that, so we leave it in place. We also see that we have enhanced safety and functionality of the project and of the end experience for every commuter. And we have enhanced flood resilience. We also think this positions New York to be a leader in infrastructure, right? This is, as we all know, a unique situation. We have a 100-year-old tunnel that was damaged by a flood of unusual circumstances. This actually gives us that opportunity to be innovative and how do we really do the right next new thing for the long term. And we think that another added benefit then is that our success here can be mapped onto other systems here in New York and elsewhere. So we have projects underway and the plans, the 2nd Avenue Phase 2, the Hudson River tunnels, and many other places where we'll be able to deploy some of the unique aspects of this very integrated design, which pulls in emerging and new technologies that have been proven elsewhere, but have never been integrated together and used to restore and rehabilitate a 100-year-old tunnel. So as you heard, what this means ultimately to New Yorkers, okay, to businesses, is that no closure of the service is necessary with this new design. We feel strongly that this is possible to execute this system design without full closure. The work can be completed with weekend and nighttime closures and doing so one tube at a time. So this leaves one train always available to do the back and forth when one tube is being repaired. I'd like to further emphasize, this has been a highly collaborative process. We've benefited so much from work that was done before, but also so much from the collaboration over the last 3 weeks with our partners, the consultants from WSP and Jacobs and from the MTA. We have presented this to the MTA, and We feel confident that they will be able to implement this, and I think we'll be hearing from the MTA next. Maybe before we move to the MTA, if any of our colleagues want to
If you don't
say a
mind,
few comments.
I'll turn it over to my
Yes.
colleagues in a second. I just wanted to add my thanks
Yes.
to all of the MTA and the consultants. In 3 weeks, I don't know how many dozens and dozens of questions we asked.
Yes.
And each,
Hundreds.
it's literally hundreds. And, you know, we can say these words, the kind of high-level statement about, you know, putting up racks and hanging the wire, but, you know, what really you have to do is you have to do that along the entire length of the tunnel. And there are tricky areas that have to be worked around. And there were lots and lots and lots of questions. And I was incredibly happy to see their willingness, day, night, weekend, Christmas Day, New Year's Day, to lend a hand to help us to understand a particular issue. And so it just seems appropriate at this point to say a genuine thank you to all of them.
Yeah,
So-
and I'd say that the level of detail behind each recommendation and the background work needed to say, do we have confidence with this recommendation, is really incredible and could not have been done without the consultants and the MTA. It has been a very much a team effort and highly collaborative, and I would also say that we never got a single bit of pushback with any question we asked. Anything we asked was addressed, which I was really such a welcoming, collaborative spirit. I think we would like, if our colleagues have anything they'd like to comment on. Tom?
If I could, I'd like to emphasize what an extraordinary opportunity the rehabilitation of this tunnel presents. Look, we're all aware in the United States that infrastructure is one of our major national challenges. Infrastructure is not only generic, but it's local. It's our infrastructure, and when it affects your community and it affects the people that you live with, and we have an opportunity to fix it locally and take a leadership position nationally and internationally, then we have a win-win situation. What we believe is that we have a design here using new technology, advancing new technology, particularly with the fiber optics and the combination with the LiDAR, to be able to monitor in great detail the structural condition of the tunnel over time. We believe that this allows New York to take a leadership position in monitoring infrastructure and bringing more effective infrastructure to the people, not only in New York, but across the United States.
Something very quick. I fully agree with what my colleague mentioned and what the two deans mentioned. This is a truly unique opportunity for New York City and New York State to become a worldwide leader. And as already mentioned, the collaboration with the consulting industry was absolutely critical in the overall process. But I would like also to mention that without the invitation coming from Governor Cuomo, nothing like this outcome could have been possible. So everything started from the invitation of Governor Cuomo, and I would like to deeply thank him for this.
Anyone else? Colleagues? Okay. Before I turn it over to the chairman, necessity is the mother of invention. A closure of 15 months was highly problematic. Necessity is the mother of invention. What these people have designed is the first of its kind in the United States of America. No rail system has used this approach before. So it really is, from their point of view, exciting. I don't know if you can tell, but these are engineers excited. they, I'm sorry, I just, the only time I saw them more excited is when we were viewing one of the subway tunnels, and someone said, "Oh, I didn't know there were so many cats down in the subway system." They were not cats. This is really a unique design, a unique system. We will deploy it here, but as you heard, this could be a national model because it is a totally different way to reconstruct a tunnel. It's faster, it's cheaper, it's better than the way we have been doing it now. And New York should be the first. And we are trying to be the first. This state is the most aggressive state in building infrastructure in the United States of America. Period. Period. No one is doing the development that we are doing. Roads, bridges, airports. The corollary to that is, let us be the state that is leading in innovation and new designs and new technology. And that's exactly what this does. This fiberglass wrapping of the bench wall, this has never been done before. I coincidentally heard about it because we had an issue with the old Tappan Zee Bridge, which was unstable, and one of the engineers recommended a fiberglass wrap to literally hold the bridge together. That's how powerful this is. The fiber optic sensors, yes, they can detect movement in the bench wall. I'm interested in them for different applications. You can tell when a worker is in that tunnel. By the way, you could tell when someone who is walking into that tunnel who doesn't belong in that tunnel and may be violating security or posing a security risk is in that tunnel. So this technology not only works for this situation, but has capacities well beyond. With that, let me turn it over to Chairman Farrar.
Thank you, Governor Cuomo, for bringing us together today and helping to assemble what I consider, and is unquestionably, world-class team from premier engineering schools at both Columbia and Cornell. To the deans, thank you for outstanding efforts researching and engineering a new approach to a critically important project for New York City. To our MTA team for refusing the temptation of being held captive to the way we've always done things, but open to new ways of doing things, better ways of doing things, and keeping forefront in our minds the reason why we're all here, the riding public. We're grateful to all of you for your help in reviewing the plans for the L train. As we take a fresh look at the L train project, we work very closely with these experts. The objective was to minimize the impact on our customers while achieving the goals of the project, to repair the L train tunnel and make it more resilient against future storms. After reviewing the proposals of the expert review team, we were thrilled that they have developed an innovative and more efficient approach, which the MTA is adopting. Based on these recommendations, we will not be shutting down the tunnel, and no full closure of service between Manhattan and Brooklyn will be necessary. No apocalypse. Instead, we'll conduct all repairs on nights and weekends, and we'll only need to close one tube at a time for repairs, allowing the second tube to run trains in both directions. Weekday and rush hour schedules will be unaffected. On nights and weekends, the L train will be running with 15 to 20-minute headways, which is no different from the current overnight service. We expect that these repairs will take between 15 and 20 months, depending on how much bench wall will need to be removed. So you might ask, well, why wasn't this approach considered earlier? The answer is that the integration of these approaches, and there are several, and the technology has not been previously applied in the context of a rehabilitation project underground. It's innovative, creative, and we deem it a sound plan. In addition, I want to make clear that despite this positive development, there remains the potential to impact our customers on weekends, which is why we still plan to implement additional subway service where it's needed, such as on the G and M lines and the 7 line. Is obviously a major shift in approach. We'll continue to work closely with local communities, the City of New York, and all of our stakeholders, and solicit their input throughout, but without a doubt, this is a less invasive, more efficient approach to rebuilding the L train tunnel for the future. And it represents a huge win for our transit system and our customers, and for that, we can all celebrate and be thankful. So thank you all. Thank you, Governor.
Well said. Thank you. Any questions?
Governor, is this contingent upon anything, any further testing you have to go through the board? And if not, and you're saying definitively this can avoid the 15-month closure, I guess the question becomes, why didn't this come up earlier? Why wasn't this thought of earlier? Why wasn't this implemented earlier?
Well, I think the chairman addressed that. This tunnel has been designed, the tunnel work was done by the preeminent companies in this country. Parsons Brinkerhoff, which is an international firm, worked on the design. These are ideas, Zach, that have been never used in this country before, never used in this application, and we are going to be the first. And as I said, mother is the necessity of invention. The way they were doing it was the best practice. That's what engineering firms were doing. By the way, that's what every other rail company in this country is doing. That's what they're talking about on new tunnel construction in this country. What this group did was they looked at the various needs, they scoured the world, came up with the best ideas across the world, and then knit together a program. Nobody has used fiber optic sensor cables on bench walls to detect motion. I don't even know what that means, actually. Nobody has ever used fiberglass wrapping on bench walls so that you don't have to replace them. This has never been done before. Now, also the context, this whole situation of tunnels underwater and salt damaged is a relatively new world, right? It's really just since Hurricane Sandy. So 6 years ago was Hurricane Sandy. 6 years sounds like a lot of time. It's not that much time for technology to develop. But the plan the MTA had was the way it was done. The best experts in the country advised them to do it. Everybody looked at it. The board has all sorts of experts on it. They all looked at it. This was a totally outside-the-box, creative solution, which was provoked, frankly, and I did provoke them and sort of give them license to come up with an idea that's outside the box, because we needed an idea outside the box. You know, there's always human nature, not just government bureaucracy nature. Human nature is to do what you have done that is tried and true. No designer wants to give you a plan that hasn't been done before. They want to go with their tried and true design. And the original design was the best practice design. But sometimes you have to be willing to think outside the box or break the box. Tappan Zee Bridge, for our engineering friends, 20 years they talked about replacing the Tappan Zee Bridge. They never did. Why? Well, there were big environmental concerns because when they built the new bridge, it could affect the ecosystem and the fish in the river. And nobody wanted to. There are important fish in the river, sturgeon are in the river, et cetera. It's been 20 years, there's no bridge. I said, is there any possible way to get around this? And we thought, and we thought, and we thought, and we came up with a bubbling system that constantly bubbles and scares the fish away, combined with a noise-making device which will scare the fish away, right? Nobody ever did it before. But this was a unique application. And that happens again and again. I'll give you another example with the MTA. Right now, the best way to put in a new signal system is the CBTC system. That is what the industry uses. That is what they deploy. Communication-based train control system. That could take 7, 8, 9, 10 years. My position doesn't work. 7, 8, 9, 10 years, I don't know that I'm going to be alive in 7 or 8, 9, 10 years. I certainly don't want to say to New Yorkers it's going to be 7, 8, 9, 10 years. I called up Tesla and I said, here's the question, we're trying to move subway cars, get them closer together, do you have any ideas? You're talking about flying cars. We're just talking about moving trains. I've spoken to other out-of-the-box companies also. I actually think there's a technology called ultra-wideband, which is going to be today's equivalent if it proves out. That'll revolutionize the signal system. But sometimes you have to push and you have to think outside the box. Nobody has done this before. I applaud the MTA for saying, we will do this even though no one else has done it. Now, just also for the public's confidence, we're talking about an electrical system within the tunnel. The tunnel itself is secure. The structure of the tunnel is secure. There is no question or risk about the tunnel. We're only talking about components within the tunnel. So if anybody says, well, they're trying something new, and it's in a tunnel, sounds frightening. It has nothing to do with the structural integrity of the tunnel. It's electric components within the tunnel. That's all we're talking about.
Governor, who's going to be holding the bag when this may prove to not be workable in the decades to come? Who's going to hold the bag if this unproven tech doesn't stand the test of time the way a tunnel rebuilding would?
Well, it has been proven because they build tunnels with the racking system, which is the primary system, right? You can go to London, you can go to Riyadh, and you will see the racking system.
This isn't a rebuild.
So,
This is a rebuild.
yeah, but it's the same. The question is, you have a tunnel which is a hole in the ground. How do you bring power to the hole in the ground? One way is through a bench wall, another way is the racking system. How do you know the racking system will work? It has been used before, and it has been used with success. Many people argue it is a better system than putting it in a bench wall. Why? Because when you think about it for a second, why would you bury a cable in a bench wall? Why would you bury a cable where you can't get at it? Why not rack it? The only thing that has not been tested, frankly, is the fiberglass wrapping on a bench wall. You know the worst case scenario there? The bench wall cracks. And then you know what you do then? We send you out with a pail of cement to patch the crack in the bench wall. That is not going to be a significant occurrence.
You can have a derailment if you crack the bench wall. And if I could rephrase my question then on the epoxy, this sounds like you're getting a patch job. You're putting a material to fill cracks and deteriorated tunnel.
No.
Why should we be confident that this is something worth pursuing and that it will stand the test
No,
of time?
anything that is unstable is removed. That's rule one, right? So if it's unstable, it's out, it's removed. That's your point, that's your problem, that's resolved. Stable stays. Something with a crack, we fill the cracks, we then secure it in addition with a fiberglass wrap. On top of that, we put a fiber sensor, so if it moves at all, we know right away.
All right, Governor, given that you've said, I think, maybe once or twice, that this has never been done in the U.S. before, what workforce and what contractor here is capable of doing this work, in any kind of reasonable time frame, and can do it, to the satisfaction and guarantee it will be done properly, since this is something from London and Singapore and Riyadh and not something from New York? And that's just my first question.
Yeah, we have done racking before. It's not a highly complicated construction venture. So we've used the racking of cables before, which is the primary method here. But I don't believe there's any special construction sophistication needed to do this, but I would refer to the experts.
So we have done, racking has been done for some cables in some of the tunnels before. Also, the negative rail has been laid on the track bed in elevated trains in New York before. So many of the different pieces have been accomplished in different contexts before. So,
Have we ever fiberglass wrapped before?
not a bench wall, but
Not bench wall, but FRP wrapping is very, very
Yes.
common rehabilitation technique for other kinds of structures.
for infrastructure.
Let me make something clear. This is not a Band-Aid. This is a real structural reinforcement. This is going to be attached to the bench wall, not only with polymers that'll glue it to the surface, but it's also going to be anchored at two places so that there's double redundancy of connecting this fiber reinforced polymer to reinforce structurally the duct bank. It is not a Band-Aid. It is a true structure.
And just your title, I couldn't, your affiliation, please?
Cornell University, Tom O'Rourke.
What happens to the
Excuse me,
contract?
let me just to follow that. As I mentioned to you before, they were talking about this fiberglass wrap to put the Tappan Zee bridge together, okay?
So this is something we've done before in the U.S.
The fiberglass wrap, as they just said, has been used many times on many structures.
Yes.
So what, and then so you told us, again, I think maybe once, that this was done, this is the first time the United States is being done. Now, it is something that has been done. We've
All
had people
integrated.
experience with, and there are contractors
No,
here.
components of it have been done.
Gotcha. Also, I mean, all the money that's been spent on preparing for the tunnel shutdown, is that just down the drain and we're never getting
No.
back?
No, most of the work, the tunnel has work going on that is not just what we're talking about. There are 3 new power substations. Stations are becoming ADA compliant. There are station enhancements. That is all work that is ongoing and was necessary. And the contingency plans that we've been putting in place, just to err on the side of caution, we're not, as the chairman said, they're not taking down the contingency planning until we are fully satisfied that this is going forward on a timely basis.
Won't this process leave corrosion and salt and mold on the inside of the wall, and why won't it eat it from the inside? Like, if it won't happen in the next 5 years, why wouldn't it happen in 20 years?
Anyone want to take that
So
question?
the corrosion was happening to the cables within the bench wall, and that is why you were experiencing a periodic issues with the cables failing. And then they'd have to be pulled out of the bench wall and then pulled back through the bench wall with new cables. That's an extremely laborious process, but we will be totally replacing the cables. So So the cables the old cables that remain in the bench walls have no functioning anymore. So there's nothing to be concerned about there. Okay, all of the cables that are functioning in the new system design are mounted on the wall. So there's no corrosion issue because we're not looking at cables embedded in the bench walls achieving the function.
You may have been also talking about the structural integrity of that wall, and as I mentioned, there's going to be this fiber optic sensor that's going to be monitoring it on a continuous basis, so that if there were sort of slow loss of structural soundness in some portion of the bench wall that initially is in good shape, we'll know that through these sensors and be able to take care of it.
What happens to the $400 million contract awarded to Judlow to do the L train shutdown? They've already been awarded the contract.
We'll be renegotiating the scope of work and the project itself. And in fact, that's sort of already begun. We're conducting tests on the bench wall and certain components of that as soon as tonight.
And Judlow will still do the work? Judlow will still do this new work?
We'll be renegotiating. We won't be rebidding this contract. We don't foresee that right now. We believe that sitting down with Judlow and working these issues out will be fine.
And the total cost will be the same?
I don't know the answer to that question. I don't think anybody does.
Have you worked out the
credibility hit
I'm
by
sorry,
this?
I can't.
Has the MTA's credibility been hit by this?
Have you worked out the cost at all, or
Have I worked out the cost at all?
has the team?
You mean on this new project?
Correct.
We believe it can be done within the envelope.
Okay, and Governor, will you promise that this will take max 20 months? Or is it possible?
I don't promise.
So other than
That is the range of 15 to 20 months. But what they said is they have to do the testing on the bench wall to determine how much of the bench wall has to come out. But their range is 15 to 20 months. But it's a silly question to say, am I going to promise on a construction schedule for an agency?
So Governor, other than the fact that you won't have to shut down the entire tunnel, why do you think this is a better approach than just gutting everything inside and getting rid of all that corrosion and rebuilding it?
There are two tunnels. The original plan was close both tunnels and do the work. This plan is leave both open during the day, close one at night and weekends. So you'll always have constant service. What can be corroded will be replaced, okay? What corrodes is the metal. The cables corrode. That's what corrodes. They're now in the duct bank. They're very hard to get to, and they're still sitting in salt water. Anything that can corrode is replaced. The racking system means all new cables, brand new insulation, all run through the tunnel.
And do you think moving forward, given that this is a 100-plus-year-old system, that this is how you would address repair and future repairs in tunnels?
There's two questions. Is the structural integrity of the tunnel fine? Yes. Well, now you're talking about the components inside the tunnel that are electrical, tend to be metal or copper, that have been affected by salt water. What's the best thing to do? Replace them ASAP, because they're going to fail. What we've been dealing with in the interim is these periodic failures. Just do it right and replace it all. This is do it right, replace it all. But don't put it back in the bench wall, do a racking system.
Can you just clarify as well, Governor? In other words, the shutdown was set to begin in April. Does this either move up or move back at all, even with the limited?
There will be no shutdown.
No, I'm saying, in other words, even the weekends you were talking about.
When do the weekends and nighttime start? I don't know, do you know?
We anticipate about the same time.
Could you just clarify the cost, because I heard on the one hand it's gonna be cheaper to do it the new way.
Chairman said within the envelope.
So it could cost the same.
If I were negotiating, I would start with those contractors as it's going to be less, because it is less work, less time, equals less money. But I am a monster to negotiate with, so.
Does the board need to approve all of this? The board? What about the board?
I don't believe so.
There were amendments to the agreement. Yes, it'll come back to the board, as it should.
Governor, since you've always told us you don't really have power over the city subway system, I mean, what faith should we have this program can or will be implemented at all?
The chairman just said it's going to be implemented.
All right, that's completely independent of you or anything you do.
I beg your pardon?
What language are you speaking today? Tell me.
I think I'm still speaking English.
That is completely independent. I said the chairman has said it's going forward. And your question is what?
And what that has, you're saying that's completely, has nothing to do with you and what you've done here or anything you've instructed him to do.
Those are 4 different questions. Pick one in the sentence.
He's saying this was your decision and not the MTA chairman. He's saying, are you in control of the MTA?
Thank you for interpreting what he said. No, I am not in charge of the MTA. Yes, I did ask this group. I convened this group. I got them access. I facilitated their research. They came up with their conclusion. They presented it to the MTA. And the MTA said it's a better way to do it, as would any normal human being, and especially anyone who had any expertise in the field.
When did you tell the MTA about this plan? When did you tell the MTA?
I never told the MTA about the plan. They were, if you heard the presentation, they were working with the MTA from the first day.
When was the conclusion told to the MTA?
It was an iterative process. They did it together. They came in, they're experts, international experts in the field, but they only know what they see and what they're told. So they started working with the MTA on day 1. And then it was an iterative, collaborative process. What do you think of this? What do you think of this? Let me show you what they did in Riyadh. Let me show you what they did in London. What do you think about this? It was an iterative, collaborative process, but it commenced together. That's why the past 2 questions missed the point. It was never a conclusion presented to the MTA. It was a conclusion they arrived at together, because it was a collegial process that they worked on together.
Did you ever mention this to Joe Lota when he was the official and so far the only confirmed MTA chairman on this? Did you ever bring it up with him?
No.
Did you ever get any pushback from the MTA? Because they were pretty certain that the big project, the big demolition had to be done. This was a must. I sat through the panels. They were
Please.
adamant it must get reconstructed.
Let me help you with that. This was almost an exact duplicate of the work we did on the Montague Tunnel. Do you remember that?
You used an epoxy to fill cracks.
No, please. What we had originally proposed for the L train was almost an exact duplicate of what we did with the Montague Tunnel, right? My first at-bat as acting chairman. And that was, and in many quarters still is, a best practice in the rail industry, mass transit in the United States. Not so in much of the rest of the world, and certainly emerging technologies are beginning to offer us some new solutions. So this is a new solution. We're excited about it. And I don't know if you do. We're excited about this. We think it's a new way of looking at an old problem. and a problem that will become more frequent to older systems, legacy systems like ours, as we're dealing with climate change and the effects of flooding. And as the governor pointed out before, electricity and electrical components don't play well with salt water.
On the epoxy though, again, considering it's untested,
It's not epoxy. You're not caulking your bathroom. It's a fiberglass wrap polymer that they use to hold the bridges together. Go ahead.
so the polymer, it worked on bridges. Why will it translate to a mass transit heavy rail system?
It is only being applied to a bench wall if there is any question about its strength. If it is unsound, it is removed. If there's any question at all, it is wrapped. You understand the only purpose of the bench wall now, the bench wall was critical because it had all the electrical conduits in it. The only function to the bench wall now is it's a walkway in case there's an emergency and a train gets stuck in a tunnel and people have to get out of the train in the tunnel. It serves as a walkway. That is the only relevance to the bench wall now.
Thanks, guys.
Thank you, guys.